Okay guys, let's start with something called as heat. So heat, what you have understood till now, it's not the same thing. It is different. So let's look at what I mean. So let's polish off few things before we get into heat. So we have understood about zeroth law of thermodynamics, right? So let's recall that. So we have zeroth law of thermodynamics, which talks about temperature as the energy that the particles of a given substance holds. Agree? So basically, more the temperature, this would imply more the, but to be a bit more specific, kinetic energy. Obviously, less the temperature, less the kinetic energy. So using this idea, we were able to define something called as absolute zero. This is the minimum possible movement per se that a particle can have. Then we went on to talk about your first law, again of thermodynamics, which talks about basically energy moves from one place to another place, but it is not destroyed per se and all of those, right? So even that was discussed. Now, so here, let me write this. This is actually important for the next discussion, that is, energy does not appear or disappear. So with all of these facts in mind, let me introduce something new. Say you have two materials. Okay, let me give some gap, it's okay. And you have connected them with a material which, well, okay, let me not do that first. So we have two materials. So one is at a higher temperature, that is, it has more kinetic energy, and another is at a bit lower temperature. So this is at higher temperature. This is at lower temperature. Now, if I give this to a way to be connected thermally, what happens? What happens with time? So here we have more energy and here we have less energy. So let me ask you guys this way. See, given something, it can be anything, honestly. Say you take it out from a fridge, or you take it out from a burning, you take it out from the gas per se. If you take it out and keep it, after some time, what happens? After some time, the material will have the room temperature. Do you guys agree? Whatever it is, either it will heat or cool down. That's the phrase that we use. We'll heat up or cool down, right? Similarly, if this is at 0th second, and after some time, say x seconds, what happens? Whatever energy this has, this too will have the same energy. Considering that this is an isolated system, that is, nothing can come in and go out. So this is just these two boxes and this rod. These two will have the same energy. But this had more energy, this had less energy. What happened? There is transfer of energy, movement of energy. Do you guys agree? So this is possible only if we see some kind of movement of energy. This movement of energy is given a name, and that's heat. Heat is not what we generally use day to day, but in physics, heat has a particular meaning, a definite meaning, and that's what we are studying. Okay, so let's have a look. So that's my lecture on heat, a small introduction. So heat is energy in transit. So I'm reading over here. Heat is not a substance. It is energy transferred from one body to another because of a temperature difference. Heat flows from higher temperature to lower temperature, right? So all of this is what is heat, right? There are a few things that we have to know. Temperature is a measure of average kinetic energy of the molecule, while heat is energy transferred due to temperature difference. This has to be very clear. Difference between temperature and heat. Okay, now with that understanding, let's look at a few more things. What changes when heat is added? When a body absorbs heat, two kind of changes may occur. Temperature change, if not phase change. So this is the next topic that we will link to. Okay, actually before this, I need to discuss one more thing. There's a mismatch. This should be the second slide and that should be the third slide. So there's one small note. Temperature does not tell you how much internal energy a system contains. So till now temperature I have not exclusively discussed, but we'll slowly add information to everything. That's what I'm doing over here. Temperature does not tell, we talk about temperature as internal energy. I kept talking about that, more energy, less energy. But it actually does not count the entire energy. Rather, it is the average. Two systems can have the same temperature but very different internal energy. Let me explain it this way. See, temperature is average. Okay, actually this should make sense. You guys are science kids. Temperature is about average. See, average of 40 and 40, or let me not take 40 and 60 is, the average is 50, right? What is the average of say, how do I put it? So let me now talk about, I need to have a lot of numbers. Yeah, actually. Oh yeah, now I can tell this. 50, 50, 50, 50. What is the average over here? Average is 50. What is the total over here though? Total is 100, but here the total is 200. So can you see that? This can be the total energy, right? This value is your average. So the two scenarios have the same average, but different total number. The total adds to different set of numbers. Why is that? How is that? Well, that's how the average concept works. Is it not? So temperature is to do with average. Your total can be anything for a given material, but the average can be same value, but the total need not be the same. So other way around is also true. The total can be same while the average can be different. Again, think of scenarios. I'm just thinking about few. You guys can think of scenarios. So temperature does not tell us how much internal energy a system contains. Two systems can have the same temperature but very different internal energy. So that total is your internal energy. Some material can absorb or release large amount of heat with only a small temperature change. So again, all this is trying to talk about temperature as an average, and you need to understand temperature as an average, not as a whole. Right? So that's about temperature. One small note. Okay, so we are looking at what happens when we add heat to system. Two things can happen. Either temperature can change or phase can change. This is something new to you guys. So let me explain it this way, and this will be done in detail as well. So temperature change. Molecules begin to move faster, right? That's what means temperature change means. The average kinetic energy increases. This causes temperature to rise. So heating of water from 2 degrees Celsius, 20 degrees Celsius to 60 degrees Celsius. Heating metal rod in a flame. So there is no phase change. So let's talk about phase change. It is known as latent heat. Here temperature does not change. Very important. Here temperature change. Here temperature is not changing. Even though you are supplying it with heat, there is supplying it with energy. You see heat. that there is movement of energy, right? Energy is being either added or removed, but the temperature is not changing. So let's see what is happening over here. So heat energy goes into breaking or forming intermolecular bonds. So that heat that we are adding, or the energy that we are adding, that's the right statement. The energy that we are adding, it's breaking the bonds or it's forming intermolecular bonds, not increasing molecular speed. See, energy has to be spent in some form. Energy, when it's spent in making the molecules move faster, that's where your temperature increases. Please understand that. Okay. So when you have, if you give some energy, so they say this is energy in form of a gas. If I see a molecule, okay, moving this much, and this is before, and this is after, and you get to see that it moves further away, it is moving faster. So this is a case of temperature increase. Now I give the energy, same amount of energy, for example, for the same material but at a different temperature. Now my before and after, I'm talking about kinetic energy at the moment. If this is the same, it looks the same average movement. If this is the same, where is the energy going? Where is this being spent? Right? This goes back to, I told you, everything is important. That's why I'm just talking in continuation. So we spoke about, where is it? Here. Energy does not appear or disappear. So if that is the case, we are not seeing movement. So what's happening? Well, this energy is used in breaking. It's used in breaking of bonds. Right? So heat energy goes into breaking or forming intermolecular bonds as well, even forming actually. So this leads to not increase in molecular speed. So ice melting at 0 degrees Celsius, water boiling at 100 degrees Celsius, all of this point, we'll see this. Steam condensing at 100 degrees Celsius. So back and forth, all of this scenario in regarding to water, we get to see this. Of course, each material has its own stuff. So this is about phase change. So this is all the things that can happen when you deal with heat. So heat as an idea over here is actually different, not what we generally use. Even I use heat in a wrong way, honestly. So heat is when you see energy in transit. Temperature is the average kinetic energy. Right? When we talk about average, the total and the average are can be two different values. Right? It gives a two different set of meaning. So temperature of two substance can be same, but the internal energy need not be. Right? So with all of that fact, with that understanding, we move on to the next topic, that is what happens to materials when we actually provide it with some energy in form of heat. So till now we have been looking at expansion, contraction and all of that. So we are diving one step more. So when does it expand? When does it contract? What exactly happens? So we are zooming in a bit more. And we get to see that materials need not just increase their temperature, but also can change their phase. When it's changing the phase, right, melting of ice, boiling of water, the temperature need not increase. So with this understanding, we'll move on to the next topic as well. So yeah, you guys can, left to you guys what you guys want to write. So I think I'll start off with this though.